Hello, I am Professor Changju Park. Today is the first of the sessions where I'm going to take a closer look at academic papers and review them for you. Many of you must be interested in implant surface. Implant surface is related to osseointegration and is a defining factor of the implant success. Recently, UV treatment proposed by Prof. Ogawa has been gaining a lot of attention. Implant manufacturers introduced numerous UV treatment technology and various lines of implant surface accordingly. UV has a broad spectrum. In the past, UVC was widely used. However, the latest trend in UV treatment is to use more powerful vacuum UV. More powerful vacuum UV can effectively push carbon from the implant surface. OSSTEM has developed a dual UV treatment protocol that utilizes both vacuum UV and UVC. The paper I'm introducing today was published in the journal Coatings in 2020. The paper shows OSSTEM's dual UV treatment technology and the effectiveness of OSSTEM's premium surface treatment, SOI. Let's first look at the key points. Titanium implants age over time. The aging leads to decrease in osseointegration ability. However, UV treatment can reverse this aging process. It improves surface wettability, which is also known as superhydrophilicity. In this paper, 3 experimental groups were set. The first group consists of conventional SA surface. The second group is conventional SA surface treated with vacuum UV. The third group consists of conventional SA surface treated with vacuum UV, followed by the application of a buffering solution, that is OSSTEM's premium surface, SOI. The SOI surface in the third group includes a buffering solution. As you may know, surgical stimulation creates an acidic environment. This acidic environment is known to work against bone formation. The buffering solution can promote osseointegration by neutralizing the acidic environment. Additionally, it facilitates rapid blood clot formation, providing a hemostatic effect. It can also help retain bone graft materials after GBR or sinus surgery. Let's take a look at each of the experiments. First, static surface wettability test was conducted to compare Group 2 and Group 3. The implants were immersed in blood to observe how quickly the blood wets the surface. The group immersed in a buffering solution showed significantly faster blood absorption compared to the group treated only with vacuum UV. This means that it is better in terms of surface wettability. In other words, the clinical difference is most evident in Group 3. The dynamic blood clot formation experiment was also attempted for the first time. In this experiment, blood was dropped at a constant rate, and when the implant formed a blood clot and sealed the opening, the blood stopped dropping, and we measured how long it took. The results clearly show that in Group 3, where the implant was treated with vacuum UV and then immersed in a buffering solution, blood clot formation occurred more quickly, thereby stopping the blood dropping. We also conducted animal experiments. Blood from all the procedure, including incision, flap reflection, drilling, and implant placement, was absorbed using gauze or cotton, and the amount was measured. When comparing groups 1, 2, and 3, the amount of blood was definitely the least in group 3, enough to be statistically significant. In summary, the rapid formation of blood clots demonstrated a strong hemostatic effect. This study delved into the initial paper that first introduced soy in 2019 and added experiments so that the settings can be similar to the actual clinical environment, making the paper more meaningful. The final conclusion. When comparing the three groups, vacuum UV treatment resulted in superhydrophilicity. The soy surface treated with buffering solution has the most hydrophilic property and has improved surface wettability and blood clot formation as well. Thus, the most successful osteogenesis can be expected. I hope you enjoyed the paper. I will be back with more interesting, clinically meaningful, and up-to-date paper for next time. Thank you.